Well, good morning. I'm really excited to be here because we're going to get really technical in a bit about how MemSQL works, how Spark works, and I think most importantly, how this is actually being deployed in a real-world environment at Pinterest. Without further ado, let me see if this clicker works. If not, oh, it does. Great. Perfect. So we'll start off with a high-level sort of overview on what's in store. We're going to chat on MemSQL at a high level. We're going to actually have real excitement around having one of our customers, Novus, speak with Novus' CTO, Rob, on how they're leveraging MemSQL. And then we'll turn it over to you at the end, Yu Yang, on how they're leveraging MemSQL and Spark together to actually do new things in data science. So we'll start off, I guess, with the MemSQL story. We are a real-time database for transactions and analytics, and I wanted to give you guys a snapshot. We started the company in early 2011. I used to work at Facebook, as did Nikita, my co-founder, and we just saw things that were being done 4 to 5 years in advance of the rest of the industry. We saw how important it would be to actually get data into memory, and we thought the right way to do it would be doing it in the database layer. So we quit Facebook pre-IPO and got to work building the company. We spent about 2 years in stealth mode, and then eventually we're able to kind of get a public release in 2013 with the full vision of the product, in-memory distributed relational database. We've seen a number of customers adopt us across a lot of different verticals. I think it really speaks to the power of the system itself, what you can do with it. And then along the way, we've collected some great investors, Excel, Khosla, In-Q-Tel as of last year. Let me go back one. There we go. So I wanted to start, I should say, on the 4 ways your database is holding you back. And this is something that Gartner collected, and this is something that came from the report. The biggest one is ETL. The fact that we are still beholden to these ETL pipelines that can be days, even weeks in the making. It really puts us at a disadvantage when we want to work and manipulate and analyze that data. Once we do start to analyze it, the analytic latency becomes a real problem. I'll share a story with you about Facebook. We were using Hadoop, and at some point, the queries were taking 26 hours to complete per query. So the inside joke at Facebook that was Hadoop would give you yesterday's insights tomorrow. And we just thought there has to be a faster way, and we started experimenting with new techniques outside of the classic HDFS and Hive ecosystem. But analytic latency is a universal problem. Slow queries, slow reports, unhappy customers, unhappy end users. And that also relates to synchronization. How can you ensure that your analytic databases and data stores are getting the latest information, and how is it still relevant to the day-to-day operations of your business? And of course, that also kind of spills into copies of data. We just have so many different ways and places to store it that we're seeing a lot of fragmentation across data sets. So these are the big barriers that Gartner has identified, and I think you guys would probably find some commonality just because it's such a universal problem. A little bit on MemSQL. This is a real-time database. It was designed from the ground up to work with modern hardware. So we're talking lots of servers, 2-socket variety, more web servers than anything. On the left-hand side, you can see the diagram of how it works, and it's linearly scalable. So you can add machines as your data set grows. And if you want to look at it from a conceptual picture, you can see that graph, which shows you that we put your data in memory for your hot, recent data. And then as that data cools off, we'll put it into a column store on the back end, and which lets you still analyze it. So it's a columnar engine. At this point, I think it'd be great to kind of introduce Rob from Novus, who can chat a little bit about how Novus is leveraging MemSQL. And I'll be more than happy to make an introduction. Hi.
All right.
Thanks, Rob.
Welcome.
That's the down button.
All right. Well, good morning, everybody. So I am the CTO at Novus Partners. My name is Rob Stepek. And what we do at Novus really quickly is we are providing an analytical platform for our clients. And our clients are allocators. Those are people like pension funds, sovereign wealth funds, university endowments. They are investing in our other type of client called a manager, what you would typically call a hedge fund. So allocators don't know much about how to pick a stock or a security. Hedge funds do. So what do? we take all of their data in every day, all of their client positions, all their P&Ls, all their transactions, everything. It's usually a fairly big mess. Imagine if you gave your tax accountant a big bag of your receipts, just dumped them on his desk and said, you figured out. That's kind of what we get from our clients. They like that because they don't have to manage their own data. So we take all that in, and we have right now about $2 trillion worth of assets. Now that sounds like a lot, and it is, but that's going to go up quite a bit as we expand in the market, especially across the globe. So we're looking at problems of scale, which is why I'm speaking with you guys today. So moving on, so where were we before MemSQL? So for us, we have a platform that provides a lot of insight and a lot of analytics very quickly. So our users are used to sub-second response time, analyzing millions of records of data, performing analytics on them, calculations, and giving them back in real time. So if you can imagine setting up a scenario, you want to look at your portfolio, you want to understand the risk, it'd be nice if you could set some parameters, push a button, and see that in real time. And we do that. Some of our competitors, these are reports that take an hour or 2 hours to run, on the back end. So you set up your report, you kick it off, you come back 2 hours later. What we do is let them tinker with the parameters online in real time and see that. So how do we do it? Well, we have to put that in memory. There's really no other way to get the kind of speed and performance we want with the amount of data we have. So where did we start? So I've been with Novus about 3 years. Before I was there, the solution was Mongo. So it's not a bad solution to start with. Mongo is free, which everybody likes, especially in a startup world. And it puts things in memory, and it's pretty fast. Reading works really great. Where we got into trouble was, so we were a very typical shop, right? At night, we loaded data. Our clients gave us their downloads. We picked them up. We loaded them into Mongo at night. And then our users read from the database for the day. And Mongo did fairly well at the reading part. Where we got into trouble is we ramped up the number of clients, the amount of data we covered. We couldn't actually write things fast enough into Mongo to really cover ourselves in that 24-hour cycle. So what was happening was we were refreshing data in the middle of the day. And so while Mongo is fairly efficient at reading, it's very bad at writing. It writes very slowly. And if we put too much pressure against Mongo on the right side, what it'll do is it'll fail over to the secondary and you'll lose all that information. So, what did that really mean for us? So a couple of things. One, if we were writing any data during the day, it was actually slowing down the rest of our clients that were just trying to read data. So again, that's really not acceptable. And there were some things we could play around with to make that better. We could shard, we could split the cluster. There was a lot of games we could play to make this a more, salable solution. But it really wasn't what we wanted to do. So what did we do next? Well, we went with MemSQL. Now, I researched a bunch of different platforms that are in this space, in-memory database, grid computing systems, and our use case is really an in-memory distributed database. So working with MemSQL was good for us because we had actually an idea of what we thought would make sense, and we didn't just talk about it. They sent a few engineers right to my shop, sat down with my code and my engineers, and we actually built a POC to prove that something I was considering for a foundational piece of our architecture would actually do what they said. So let's talk about what that actually did for us. So before, if I was to go and let's just say scrap all of my data, all of it, and replace it all from scratch, just to say we had a fundamental change in our data model. We've never done that, but if I did, it would take me 3 to 4 days to actually do all that by pushing it back into Mongo. With MemSQL, I can reload our whole data set in about 4 hours. That's pretty amazing for me. Now, what that really means in terms of like our single client, one of our largest clients has thousands and thousands of positions. They also manage hundreds of separate funds. It's a lot of data. Almost a terabyte of data just for this one client. And before, if I wanted to re-clear in all their data and retag it, it would take me about 3 to 4 hours. I can do it in 2 minutes now with MemSQL. So I went from a cycle of data refreshing that was essentially going around the clock to just an hour or 2 at night. And what does that really mean for me? Why is that important? Well, because now I can actually scale. We're adding clients pretty rapidly. And for me, scaling was before with Mongo, it was an engineering problem. We would have our engineers come up with new and clever ways to deal with some of the issues we have. For example, for a database, Mongo was very bad at putting things in writing and also was very bad at deleting. So what did I do? I actually had to write like almost a memory manager to not delete records from Mongo, but to actually tag them for reuse. I don't want engineers doing that, right? That's not what we're good at. We should be building our products. So now, if I want to scale, I have my own data center. If I need to add some capacity, I buy a few more of my Dell blades. I put them in the server. My ops guys run Chef. It deploys the software. I have 2 new nodes, and away I go, right? 2 new leaves. I can tell it when to redistribute. No engineers get involved, and I can do this all day long for as long as I go on, and I never have I don't have to worry about resharding, any of that stuff. So on top of that, again, with a system that was being pushed to its limits, what did that really mean for my engineering staff? Well, I wouldn't call it hand-holding per se. I think that's an interesting term, but we were very carefully watching those systems. You know, we had a lot of monitoring, and there was a lot of times where it needed to be, let's call it, caressed a bit to keep things online. So all of that's gone away right now. So, you know, we talked a little bit about this before. I mean, I think it's pretty clear what I said. I mean, before, we had things that took, you know, this is the type of scale that I went to, 90 minutes to 2. I mean, and this is fairly common for us across the boards. All right, well, I think that's it. I just wanted to mention one other thing. The other nice thing that I've gotten around with MemSQL is the way that the redundancy works for me right now is very seamless. So one of the problems we had with Mongo is if we wanted to add things to our cluster, rebalancing happened on their terms. Now, of course, what that really meant was that I would assume my cluster would rebalance at 9:30 in the morning on the busiest trading day of the year when every one of my clients was logged in, right? Which is how it always goes, right? And everybody would be slowed down and, you know, completely, you know, ringing every phone in my office off the hook. With MemSQL, I can control rebalancing. So if I want to add a bunch of things to my cluster, I can do it, of course, way ahead of time, but I can decide when to rebalance. Now, we've done some tests with it. It doesn't really slow down the cluster, but I can still control that, which to me is very important. And last point I'll make that really helped us in terms of our coding aspect was when we used Mongo, one of the things that they didn't have initially was, believe it or not, aggregation. So I couldn't aggregate at the database level, which is, of course, what databases are very good at. So we had a ton of complex code to aggregate on the front end of our, you know, of our code. That has all been removed, which is great for, of course, clarity and simplification of our code base. But more importantly, all those operations happen on the database. So everything on my platform that dealt with aggregation, which is essentially everything we do, has now done a database. So everything, I picked up like 100% speed increase on all of my aggregation. So again, a huge benefit for us in terms of our client experience and our user experience. So that's it for me. I really appreciate your attention. Thank you very much.
Thank you, Rob. Thank you. Thanks, Rob. There we go. All right. Well, I hope you guys found that really interesting. Just sort of the speed and scale that many of our customers operate at. Having that deterministic performance is one of the benefits of working with in-memory systems, and putting a transactional wrapper or a transactional engine inside of that data structure is really, really important too, especially when you're working with financial data. So I guess we're going to be transitioning over to sort of Spark developments and how this is actually architected with Pinterest, which is coming next. We all know interest in Spark is just through the roof. It's red hot. You know, a recent survey of 2,100 developers basically deduced and concluded that 82% would choose Spark over MapReduce. Another 78% did need faster processing. So MapReduce is just really not the right implementation to proceed in the next few years. And then you can just see that, you know, the results are pretty compelling. Spark is going to replace MapReduce. And I think we're all here together in this room to kind of learn about how and what we can do to affect that in our organizations. If you guys aren't familiar with Spark, I thought it'd be worthwhile to kind of start at a high level, just to explain what Spark can do. Spark is a processing engine. It relies on other systems like MemSQL and other operating stores to provide transactionality and durability. But in exchange, you get a very fluid, very expressive execution engine. You can plug into Spark Streaming. You can plug into a library called MLlib, which gives you the ability to run iterative machine learning algorithms on your data. And you can also plug in a GraphX plugin that lets you run sort of graph theory or graph modeling on that data. Spark SQL is at this juncture more of a pure analytic exploration, so you might use it to do simple exploration of your data, but it's not providing transactionality, durability, or consistency. It's just there to explore at a high level what's in Spark. And of course, all of that sits on top of the Spark framework. So we need to find simple ways to use Spark in the enterprise. We believe that by operationalizing Spark, it lets data scientists have more impact. That was basically the gist of the keynote this morning, was how can we go from just making insight as data scientists to making impact and really affecting the business with real-time models that affect what users see, what happens when a market changes, what happens on a last click. So we believe that putting an in-memory system next to another in-memory system is the proper way to do it. Of course, Spark works very nicely with HDFS, but as soon as you go and hit HDFS, you're getting choked on disk. And that's a real big problem when we think about latency. So having an in-memory distributed database communicating with an in-memory distributed execution engine like Spark gives data scientists a lot of power. we can start out about what this means between the two systems. First, of course, is that those arrows indicate a connector between MemSQL and Apache Spark. That connector is open source, and I encourage you guys to go and check it out at github.com/memsql, where you'll find the connector. What's interesting about that is that it's a novel invention that does basically multi-threaded data passback. The standard ODBC is single-threaded. This thing can actually basically map partitions in MemSQL to RDDs and other partitions in Spark. So we have similar architectures. So cluster-wide parallelization, this means that you can shuttle data very, very quickly between the two systems. And it's bidirectional, so Spark can push into MemSQL and vice versa. And this gives you just a lot of versatility as you want to build a model. And we have some use cases to share, just to kind of start the conversation for you as you sort of explore Spark in your organization. The first of which is operationalizing models built in Spark. So the idea here is that the model that we've created as data scientists can be actively given to an application and an engineering org to use. It's basically something where you can actually feed data into the model that's actually real time and feed it back out with a recommendation or a decision or a repin or some sort of new action that is suggested to the user. You might use machine learning to process that, for example. The other thing that we have focused on is stream and event processing. As we have more sensors, this is just so important to learn how to work with a modern implementation of streaming. Spark is that modern implementation. With Spark streaming, you can do in-place transformations, sanitize the data live, and then get it into a system like MemSQL for reporting, which touches on the third use case. The ability to see what's going on. Live dashboards, real-time reporting is very important, and of course the ability to automate that. So you really need these two systems to guarantee this type of performance. And then I think what's really interesting, just to touch on what MemSQL does, it's in our name, we're a SQL database. But there are certain computer science problems that are just not SQL oriented. And we really believe that the way to extend SQL is to work with non-SQL type of implementations inclusive of Spark. So the ability to run custom analytics that you just wouldn't express in SQL but you want to reference, we see this as a very interesting, let's call it 21st century extensibility story, where we're no longer necessarily relying on UDFs or UDAs, we can actually reference a Spark function. So let's start off with the first use case, operationalizing models built inside of Spark. The first job is to process your data in Spark. On the left-hand side, you see that data goes into Spark. You're going to basically create a model, iterate upon it, and then you're going to persist it into a database to basically get it consumed by the enterprise. I think this is the biggest use case for Spark at this juncture, which is that Spark is not designed for broad consumption of the data. It's designed for maybe one or two data scientists to be accessing at once. But what happens when you've decided this is the model I want, this is the data that I want to share with the enterprise? You need a system that can federate, propagate, and basically broadcast that data out to your organization and even to your end users, whether those are visitors or whatnot. So that's really important to basically get that broad-scale enterprise consumption. MemSQL as the database can do that. You can power an application leveraging this technology. And what it ultimately lets you do is go into production and iterate faster. We can talk on the streaming use case. In this idea, you basically want to take streaming data in, transform it using Spark, and then once again put it in a persistent queryable format. So this ability to basically leverage SQL, which is universal in every single enterprise, is going to get your data science teams have broader impact. And no longer will sort of data be constrained to a certain team. You can now basically have the ability to broadcast this recent data out to an organization. Maybe one of your business groups needs to connect it to Tableau. That's a great example of empowering sort of quasi-technical teams that know SQL, know how to actually leverage BI, and they still get access to the same data that you are working with, working in Spark. And that's, again, getting back to enterprise consumption. Extending MemSQL analytics. This is really cool because you can perform interactive analytics and machine learning inside of Spark, which is, again, just a natural custom analytics that every business is going to use. But the important thing here is that you're getting access to live production data. So this is something where you're not seeing stale data. You're not getting that partial view. You're actually seeing what's happening as it's happening, which means, of course, that you have the chance to make that impact in the organization, change how the business is running. In this particular instance, we have a MemSQL replica set up so that you can decouple the application and the data streams flowing into the MemSQL database. So this is to demonstrate sort of the performance of real-time cross-data center replication and having a replica as well, so that your data science teams can basically point to a replica and not have to worry at all about the application database itself being sort of clogged or whatever have you. But this is a standard example about how you can extend those analytics and then pass that data back and forth between the two systems. The last one we'll chat on is live dashboards and automated reporting. Typically, you might perform custom reporting via Spark, but the other thing is that you can leverage a standard ODBC or JDBC connector to connect MemSQL to a BI tool, whether that's Tableau or MicroStrategy, or even to build your own custom in-house dashboards. It's much easier to just work with a SQL output as a result set. And again, leveraging this data gives you this ability to put that on its dashboard somewhere on a big screen TV and show what's happening with the business. I hope to have a few minutes for questions after, so we can definitely touch on these examples. But at this point, I'd like to introduce Yu Yang, who's a senior software engineer at Pinterest. And he's going to be chatting about how they have leveraged MemSQL Apache Spark and the connector to do some really, really cool things. So, Yu?
Okay, thank you, Eric. Okay, thank you. So, and here I'm going to talk about how we are going to we use MemSQL and along with the Spark streaming to do the real-time analytics at Pinterest. So we are building a prototype that's helping our data analysts to gain insights on the real-time data. So this is so first, let me give you a brief introduction on our logging pipeline. So in Pinterest, we collect a lot of data to understand the user behavior and to help us to serve users, to serve our pinners better. So the way we do is first we collect the logs at our application servers, where the logs is shipped to Kafka brokers to as a central transportation repository, where it will take two paths. In one path, we are going to take the data into the S3 to process the data into S3 using the Secure, one of our homegrown technology that we have open sourced. From there, we were using Hadoop and other MapReduce technologies like the cascading, etc., to do the daily processing. Meanwhile, we want to gain some real-time insights into our data so that to help our pinners to get better experience with Pinterest. For example, one question we want to answer is, what are the trending pings the pinners are seeing in each area, right? For instance, on the East Coast, the trending pings may be different from what we have on the West Coast. All those questions, how can we answer them efficiently, right? This is a problem that we are going to solve, and this is where we think Spark streaming plus MemSQL can be a good solution here. So, and in this prototype we built with MemSQL, the way we do is first we use Spark to stream the data from the Kafka into the MemSQL, and from there, then we build a few analytics tools and help us to gain insights into MemSQL. So first, let's talk about why we are going to use Spark here. So there are a lot of the streaming technologies like the Samza, Storm, but the reason we choose Spark is there are a few reasons we choose Spark. First, we have a high volume of traffic, user traffic. We need a scalable system to handle this high volume traffic. The second, and also the reason we use Spark is right now, Spark gains a lot of traction and is a leading technology in streaming processing. And also the micro-batch, Spark using micro-batch to do the streaming processing. It works well with our offline batch systems. So it gives a nice way for us to uniform the micro-batch and daily offline computation, so that with one piece of code, we may doing the job for both. Right. I think this is one of the reasons we choose Spark. And here in details, the way it works, as I mentioned earlier in the slides, is first, when the events hits our application server, and we use our logging agent to upload the logs to Kafka, and from there, we process. We're using the MemSQL Spark transporter to stream it into MemSQL. And from there, we will go to, and we process. During the Spark streaming, one thing we not only just do the data transportation, but also we do some data filtering and data enrichment. For each event we get from this, and we may look at a bunch of other services and get all the other enriched data and put that data into MemSQL so that it will help us to gain the real-time insights into our data. And all these happens pretty fast. And the whole pipeline from the events is being hit by the server to where we can do the analyze. To analyze the data, it only takes about less than 1 second to get this. I think due to the network connectivity issue, I'm not sure whether I can do a live demo here, but here is a video we have prepared about showing what we have built using the Spark plus MemSQL, and also some analytics tools, visualization front end. So in this demo, what we want to answer is, so what are the trending pains in the United States, maybe for a sample of data in the last 5 minutes, right? And from this demo, you can see that, and we use MemSQL can aggregate the data in real time about in each geolocation. So what are how many pings we get at the city, state, and also the whole country level. And also, from there, we can do some query like given each city, for instance, in San Jose, right? What are the trending pings, trending topics in this area? We can see. And also, for instance, in other area, what are the trending pings? And when we zoom in to for instance, Chicago, we can see what are happening where are the pingers, ping the ping to Pinterest. Yeah. I think this is give an overview on, a high-level overview on we're using Spark streaming plus MemSQL to do real-time analytics at Pinterest. Okay, thank you. So now I'm going to handle this to Eric to continue the presentation.
Thank you. Thanks, you. So, at this point, I think it's a really great opportunity to have some questions for both Rob and you. Of course, come by, stop, and play some Query Kong with us. We're giving away a really cool micro drone. I actually saw this for the first time this morning, and I can't believe how small these drones are getting. So more sensors, more devices, that's the theme. So at this point, I would love to open it up for Q&A. If you guys have any questions, it's across the board. We're happy to answer. So who should we start? All right, we saw the hand go up first over there.
Does MemSQL actually use Tachyon and other parts of Spark which are involving the
Sure.
How does that integration work in the future? May not use case.
So the question was, how does MemSQL leverage Tachyon and other sort of components within the Spark framework? In a word, no. We started the company back in 2011. So a lot of the infrastructure to build MemSQL was built in-house on C++, which means the system is designed to have its own memory managers, memory allocators, scheduler. A lot of heavy lifting went in to build a real-time database. And connecting with Spark is actually a transformer, or as you mentioned, and it's really interesting to see these two systems work so nicely together. Over there.
I was wondering if you could talk a little about the schema that was used for the Pinterest visualization that we saw, in particular how, deduping of duplicated events as they come in on the stream is handled.
Sure. So I think this question is for you. So if you want to come on up, you, and talk a bit on sort of how the Pinterest team is sort of deduping the data as it streams into the system.
Okay, so the way we do is first we will have when we read the events from Kafka, and the events are we will have some dedupe as real buffer events because the user's events usually comes within a time span, right? During the time span, assuming that the events will comes within the 10, the lag of the events is around 10 minutes. Within the 10 minutes, we given the rolling 10 minutes time span, we dedupe the events in that way, right? The second is and for the ping and reping events, that usually we don't see too many duplications. So this is another reason for having to solve. And so we just give about 10 minutes time span to avoid the check for the duplication and persist to the MemSQL. Yeah, I think that's.
Yes, up front.
Yeah, so I'm just trying to get a feel of how with the Spark SQL now that is getting some traction.
Mm-hmm.
How do you see when MemSQL, what's the relevance of that once Spark SQL gets more mature?
It's a great question. So the question was, what are the big differences between Spark SQL and MemSQL? There's a lot of differences. One, of course, is that the MemSQL engine is more robust as a function of being able to perform distributed joins, more aggregate functions, more partition over functions, things that are classically complex SQL. The other thing I should say is MemSQL also has built-in durability and transactionality and consistency. Spark SQL is a way to grab data that's inside of the Spark side of the house, but it's really there just for the select. You can't do an insert or an update that's going to basically give you that durability. So when you put data into Spark, you have to be cognizant that it's a temporary placeholder, temporary sort of loading zone, if you will. You'll manipulate the data inside of Spark, but then you need to move it elsewhere to guarantee that it's ultimately a durable piece of data. Yes, over there.
I actually have a couple of questions. One is, how do you work with Cassandra?
Mm-hmm.
And then two is, so if we already have a cloud data cluster, right? So can I leverage HDFS for persistence, final persistence, or is this going to be separate?
Yeah, no, we work with any. So the question was, how does this work with a file system like HDFS and an existing Cloudera cluster? We work with any file system, whether it's XDF4, for example, or HDFS. I think it's a really good to mention a customer example about how you can leverage Hadoop and MemSQL. Comcast is one of our public customers that leverages a lot of infrastructure to manage their video processing network. They leverage Hadoop. They have MapReduce for their engineers. And then they added MemSQL into the picture to expose that real-time data via Storm, in this case, to get persistence of that data as well as exposure to other business groups via SQL. So it's that real SQL access that opens up this data to more groups. And the difference between, the other question was, what's the difference between Cassandra and MemSQL? Both distribute, both are pretty fast, but the SQL element is something that is unique to MemSQL in versus Cassandra as a key value store versus a fully relational database. Yes, all the way in the back if you're waiting.
Yeah, would you recommend using MemSQL as a data warehouse for long-term storage of data?
The question was, is it recommended to possibly use MemSQL as a long-term storage for data akin to a data warehouse? We have several customers that store their data mainly in the column engine and put some of the data in memory for that T0 data. The column engine inside of the system is just a table type. So it's not a really difficult thing to work with. You could create a table in memory, and then you can create a table on flash or disk that will basically compress that data for you. So a lot of our customers are seeing 5, 6, 7x compression ratios, where they can put 7 terabytes of data into the system, and then it's only physically 1 terabyte on the flash or disk mechanism. The beautiful thing there is that you have one interface that can span your real-time data needs as well as your historical data needs, which makes it very interesting when you want to do trend analysis. You can say what's happening today versus what happened a year ago. One interface and one query can answer that question for you. In the middle, yes.
Can you share some of the scale that you guys are dealing with in terms of the size of the MemSQL environment and how many transactions are flowing through a year?
Sure, absolutely. So within the Pinterest demo itself, we're talking tens of thousands of events per second flowing in. In terms of the actual physical scale that some of other customers are deploying at, we have one customer with 500 machines, and that's a commercial environment. Our federal business can't disclose those numbers, but they're much bigger. So the system is designed to be linearly scalable. You can add a machine and get a commensurate amount of compute and a commensurate amount of storage, which is really nice to kind of always have a perfect ratio between core count and gigabyte count. This over in the back. Sure. The question was, does MemSQL work in the cloud? And I guess what were the reasons were for the Pinterest data science team to push into S3 as well as into Spark and MemSQL? I'll take the first crack, and then you, by all means, share in. So yes, MemSQL does work in the cloud. In fact, most of our demos that we're doing are all on AWS. You can go to cloud.memsql.com and actually click a button, and within 5 minutes, Amazon will build you a arbitrarily sized cluster of MemSQL. And then I'll hand it over to you to answer sort of how they designed the system to work on Amazon.
Yeah, actually. In this demo, we work with MemSQL. All the deployments happen in the AWS cloud. So the reason we just put the emphasize Spark plus MemSQL in the separate chart. But the reason and the difference between the MemSQL and S3 is S3 is a persistent storage, but MemSQL is all about real-time data that we care about. So yeah.
Yes, over there.
How do you distinguish MemSQL from other in-memory databases such as Spike or something?
So the question was, what are the distinguishing factors for MemSQL, vis-a-vis other in-memory sort of data stores? The biggest one is that you get the full SQL ANSI SQL access. So you mentioned Aerospike, their key value. That's really limiting. End of story, really. I mean, working with a transactional workload, a key value system is nice. It can work, certainly. But then what happens when you need to analyze that data? So the real distinguishing factor for MemSQL is that you can do in situ analysis of that data using a real-time join. And we've worked really hard at the company to build up this very robust SQL framework and SQL engine that can basically run real-time analytics. This is something that you might call transactional analytics, the ability to basically run live analytical queries on top of live transaction data. So the biggest one is the SQL access and the analytic SQL that it provides.
How does MemSQL compare to Redshift?
Redshift. Okay, great question. The question was, how does MemSQL compare to Redshift? The high level is Redshift is a classic data warehousing technology. It's formerly par Excel. Was more in sort of the league of a Vertica, Netezza, Greenplum sort of level. So the short answer is Redshift is designed to be a batched processing system.
So can someone replace Redshift?
It definitely can hold a lot of data. MemSQL has customers that are inserting 10 billion data points a day into the system that then are processed in memory and compacted for long-term storage on flash or disk. These are mainly our advertising customers. Yes, hundreds of terabytes. We have some customers that in the non-commercial space on the petabyte scale already. And the beautiful thing here is that Redshift and other technologies like that do work, but they are basically giving you only batched processing. And the ability to kind of get a system that can do real-time processing is the real sort of next phase for big data. So going back to what is the next phase, it's going real-time. It's getting faster so that we can actually work with terabytes of data at our fingertips without having to really sweat over it. A SQL query that can do that is a nice way to expose that data elsewhere. So I think we have time for just a couple more questions before we wrap. Yes?
How do you customize MemSQL, like new UDLs and stuff?
So customization, the question was, how does MemSQL perform like sort of custom analytics? And the answer is Spark. The ability to write these custom analytical jobs inside of Spark and then reference them inside of the SQL query is actually really nice. So this is sort of the next phase of UDF, UDA. And I think we have one last one. Yes, sir.
So the MemSQL, does it have support of secondary indexes? That's one. And then the other is out of the box in terms of analytics. What is the set? Is it like hundreds, thousands?
The first question was, I'm sorry. Oh yes, the support of secondary indexes, absolutely. So that's one of the other things with a SQL system is that you can have primary and secondary indexes and as many as you like. So you can have multiple indexes on the same table that are maintained, updated with every single transactional update. And then the last question that the gentleman had related to sort of what's the extensibility story or the analytical capabilities. And you want to use MemSQL as a in-database analytical engine. So the ability to ask a query to the database is going to do the aggregates for you. It's going to do the statistical functions, the group by, the order by. It just is designed to basically take all the heavy lifting off your plate, let the database do the hard work, and then you get the results that you need for further analysis and customization. So we're really excited about what MemSQL and Spark are doing together. They're extremely complementary, and I encourage you guys to really start experimenting with Spark because it is going to be the next sort of phase to replace MapReduce. And then in terms of going real time, go to our booth to learn more. We're doing multiple demos. One of them is Oracle's own demo, and we're doing it 60 times faster. Because we actually have sort order in our system and Oracle does not. And we run on commodity hardware when Oracle's running on an Exadata. So it's also 60 times cheaper. So you can see how quick it is to scan 30 billion records in 4 machines running on Amazon. We're running the Pinterest demo live, and then we're also running an ingest demo to show you that the system is designed to handle hundreds of thousands of inserts per second. So this is all designed to make your lives easier. Less time loading data, more time analyzing it and getting access to real-time data. And by doing that, I think we do go from making insight to actually making impact directly on the organization. So thank you very much, guys.